Hello, in this video we're going to continue to explore the graphing of a quadratic relationship, sometimes called a quadratic function, and we're going to look at the specific situation when you put a constant term in front of the x squared. So notice here this would be 1x squared, it's 3x squared, 1/4 x squared, negative 2x squared. So what we want to do is fill in this table of values, but before I do that I want to make just a little observation here. So we could say that the relationship is written as y equals x squared. So now let's carry this relationship into our other examples here. So instead of saying 3x squared, we could write this as 3y because we know x squared is y. We could write this as 1/4y. We could write this as negative 2y. So what I want to do here is I want to stress the idea of the connection between x squared here and where x squared shows up in each of these cases relative to the constant. Okay? So let's fill in this table of values, shall we? So negative 3 squared is 9, 4, negative 2 squared, negative 1 squared is 1, 0, 1, 4, 9. And what I notice, my little check here to see that I've done this correctly, is my check here is the symmetry that I see. So I notice that we have, this is my vertex here, 0, 0, which we know x squared, the vertex is at 0, 0, and I see I have 1, 1, 4, 4, 9, 9. So one way to fill in this next section of my chart, next row, is to calculate the value by substituting in the x value. So if x is negative 3 squared is 9. So this is like saying 3 times negative 3 squared. So negative 3 squared is 9. 9 times 3 is 27. So this is like saying 3 times 9, which is equal to 27. Negative 2 squared is 4, so that's like saying 3 times 4, which is 12. Negative 1 squared is 1, so this is like saying 3 times 1, which is 3. 0 squared is 0, so this is like saying 3 times 0, which is 0. And then we get, if we continue, we get 3, 12, 27. So we definitely should be comfortable with the idea of how we substitute in the value here. But one observation to make here is notice, this is 3 times 9. Notice in x squared, this is 9. It's 3 times 4, well, x squared is 4. 3 times 1, x squared is 1. So notice what we're doing is we're actually taking the x squared value and multiplying it by 3. So we're taking the y value and multiplying it by 3. So if we substitute this next one in, again, this one is 1/4 x squared, so it's going to be 9 times 1/4. So I'm going to write this as 9/4. This one is 4/4, which is equal to 1. This one is 1/4, and I'm going to leave it like that. I'm not going to write a decimal. This is 0/4, which is 0. 1/4, 4/4, which is 1, and 9/4, which we leave. Then our last set of values, so negative 3. So we have 9. 9 times negative 2 is going to give me negative 18. Four times negative 2 will give me negative 8. 1 times negative 2 will give me negative 2. 0. And again, that symmetry kind of pops up again. We always want to keep an eye out for this symmetry because it's a really nice thing to pick up on. So this table of values is pretty straightforward to complete. We can simply take the x value and substitute it into each of these cases here. But what we want to kind of link here, the connection we want to make, is the connection between the x squared and each of these subsequent rows. So if we think about x squared as being y, we're essentially taking the y value and multiplying it by whatever the coefficient is in front of the x. The coefficient being the value right there. 1/4 is the coefficient, -2 is the coefficient. In the next video, we'll talk about what does this mean graphically.